All right, my turn for a ride. Oh, this is a fun job.
This is a fun job. You get to drive people around and show them a very, very cool truck.
This is so fun. Sending it, nice. Full ABS, into the turn, hit the apex. That's awesome. It's like your own little racetrack out here.
Yeah.
You set lap times and everything.
Yeah.
All right, I got Matt here, another senior principal engineer, and also has a really cool hat that I need to get at some point. But this is an actual Toyota fuel cell generator, and I just wanted to get, I don't know, tell us the rundown of how this thing works.
Sure. So we made this as a demonstrator for us to really learn more about systems integration, the kind of type of integration that our customer would do, would need to do to put together and package this fuel cell module for an actual stationary application. So in this context, you can see in the center here is our actual fuel cell module. This is a type 1 configuration, which is more like a cube. We also make a fuel cell module that's more kind of a long box. It's a type 2 design. Underneath it are a bank of supercapacitors. These don't have a whole lot of energy. It's really is a power buffer, kind of the same as a Toyota Prius or a Toyota Mirai, and that the battery is there, or the energy storage there, is to kind of absorb kind of peaks, both like an XLD cell or a power up or a power down, depending on the load for the application. And so this allowed us to integrate supercapacitors with the fuel cell, with an inverter, to be able to provide, you know, a same type of kind of a drop-in replacement for a conventional, you know, gasoline or diesel-powered genset. Okay. And the format of the box itself is very similar. So what you'll see is kind of a dividing line here with the radiators that is providing cooling for the fuel cell and for the system. We also have some air-cooled supercaps, as well as the rest of the kind of electronics are air-cooled. And then if you kind of walk over here to the side, you can kind of see this is our exhaust area. So it's again very similar to a conventional generator, where we have the large radiator fan pulling air through the radiator that's doing most of the cooling and also providing ventilation, and then exhausting the air upwards. Again, very similar to a conventional system. And then this large tank right here is actually a separator that allows us to take the fuel cell exhaust. There is, you know, water. It's a saturated, you know, vapor stream. So even if you're exhausting that upwards, you're still going to be condensing water. And some customers may want to use that, or they may not want to have condensed water kind of raining out from the top. And so we're able to knock that out and actually have a separate outlet at the bottom. That's what this black hose is for. We have our hydrogen supply system, which kind of regulates the system for the hydrogen into the fuel cell, and that's kind of similar on the other side here. If we walk around, we can see kind of the outlets here. These AC outlets are both 120 volt, 208, 480 volt AC. This is similar to what you would have in a conventional system. Nice. And so this kind of really allows us to kind of learn about the different aspects of integration. It also allows us to learn about certification. So to do something like this, we would need to be certified if it were to be a product. Okay. And there's certain design elements that comes with that, design approaches and sensors that you would need to have incorporated to be able to meet those requirements for certification. So got it. That was kind of the learning opportunity for us. Yeah, so the application is really just anytime you'd normally use a diesel generator, this would kind of slot in place of that. And then as far as, you know, hydrogen storage, it's not so much on this exactly, but it's like you can use however much storage you need. So you could have like a pack of, I don't know, 5 tanks, 1 tank. Correct. Just depending on your use case. That's correct. So hydrogen for kind of a commercial application is relatively easy to get. There's a number of suppliers that are out there. So you can get bottles, or you could get actually a trailer
Nice, yeah.
right? So it just really depends on your endurance, your mission profile as far as how long you want to run at what power level, kind of judges how much hydrogen you would want to have.
Yep. Awesome. So yeah, great use case out here. I mean, obviously even charging just a couple, a battery electric, but also a plug-in hybrid. Yeah, makes sense. Pretty cool. Pretty neat to see all this lined out, and so much fun. And the supercapacitor, there's like 3 of them in there, is that?
It's 4 super caps.
4, okay.
One's kind of hidden underneath.
Yeah. Okay.
Just the way the packaging was.
And
Yeah.
how much power do those actually hold?
Well, it's so this is kind of the stack itself can put out 80 kilowatts.
Okay.
We've kind of rated this at about 70 kilowatts net. And so the super caps can provide that kind of power as a pulse power. But it's really about how much energy. We're not disclosing how much actual kilowatt hours it is, but it's basically enough for us as a supercapacitor to be able to allow buffering for transients based on load. And then so basically it's working as a hybrid in the same way a Toyota Mirai would work.
Very cool. A hybrid, but a generator. That's awesome. All right, back with Matt out here behind the building. We actually have a hydrogen filling station, which Kyle's already done a video on how to actually fill a Mirai, for example. But I actually wanted to find out, why you have this here. I mean, obviously you're working on hydrogen and stuff, and you actually have direct lines into like the dyno and stuff, which we already saw.
Yep.
But you have this available to like Toyota customers. How does that work?
Yeah, so for Toyota customers, it's on a limited basis. We do it during kind of selected days during the week for kind of limited hours. And we have an attendant that provides that fueling. And that was really done as a way to kind of help out in the local market. We had a couple of stations go offline for kind of a number of months. And so we wanted to provide customers a pathway for them to be able to still get fuel. And so that was about 2 years ago. And so kind of it's stuck, and there was a lot of popularity, and so we've just kept it open since then. And so right now we usually fill about 20 customers per day.
Oh wow.
Depending on kind of how we're able to do that.
Super cool. Yeah, awesome to have this out here. And I mean, how many like filling stations are there in California? Do you know?
Oh, that's a great question. I would point you to the Hydrogen Fuel Cell Partnership website.
Yeah.
There's a page that's on that website called By the Numbers, and that gives you the actual list of stations that are built and operating today, and also a list of all the stations and addresses or areas of stations that are in development.
Yeah.
And so for this station here specifically, the reason that we put this in was actually part of our development.
Okay.
So we wanted to be able to evaluate the fueling protocol and the fueling performance of this station with our prototype vehicles. We also wanted to be able to fill our prototype vehicles without having to take them to a public station. And we also wanted, for the heavy-duty side, for our heavy-duty trucks, be able to evaluate the fuel performance for that protocol for the trucks. So that was kind of the primary background for that station. And as you mentioned earlier, it also provides a hydrogen supply to our test benches inside the building. And also, we actually walk over here. It actually allows us to evaluate certain components. And so for this dispenser here, this is from Tatsuno. This is a Japanese company. This is one of the first sites outside of Japan that both Tatsuno and Kabelco, which is the maker of the rest of the equipment, made the first system outside of Japan. In this case here, this nozzle is from Nito Kogi. This is not available on the U.S. market yet, but that's something that they're evaluating. So we're evaluating them with them, being able to collect data and the experience of fueling the vehicles here, so we can help this company be able to come to the U.S. market.
Awesome. Yeah, a lot of testing happening. That's a cool looking nozzle too. Over here we have a Kenworth T680 hydrogen truck with 60 kilograms worth of tanks plugged into a Shell heavy-duty filling station. Now, notably, Shell has kind of ditched the light-duty hydrogen game, which is upsetting some people, I think, but seems like they're full send on the heavy-duty situation. So right here, this truck will sit here plugged in. It'll be charging, well, not charging, filling for about 30 minutes if it's really empty to get full hydrogen once again. And over here, not far from the actual truck filling station, is the hydrogen, I guess, junction where they get it. Some of it from Trigen, but they also point out they do get some hydrogen brought in by trucks if they need to. So it just depends how much hydrogen they actually need, what's the demand, they can usually meet it. This right here is a really cool solution as well. No, this is not a hydrogen Tundra, but it's clearly a Tundra TRD Pro kitted out with some interesting stuff. It looks like some aftermarket stuff. I actually don't know enough about Toyota's offerings to know what's aftermarket, but there are like rock lights down there, which is kind of hilarious. That's pretty fun. But the main news is not the cool kit on this Tundra. It's actually what is in the bed itself. And this is a hydrogen power station. Basically a Mirai powertrain is in here, and this thing can be used as a mobile power station. Now, there are no tanks on here, and that's because to carry hydrogen tanks, you have to have special hazmat. Like, there's special stuff required to transport hydrogen. So instead of this being the tanks and everything, it's just the power generator. It has the Mirai fuel cell power situation, kind of like the cube setup we saw in the actual test center from earlier in the video. And this just plugs into existing tanks. So they take tanks out to the desert or wherever a racetrack is. They made a point that with races and things like that, a lot of times the actual carbon footprint is most affected by the actual infrastructure and the tents and like all the diesel generation. And it's, yeah, this is one way to save on that quite a bit. So pretty cool to see this in action here. And they're actually literally are using it. They're powering all the stuff over there off of this thing, which is super cool. So very applicable. I don't remember the actual power output, but it's definitely a better option than a diesel generator and quieter actually. And of course, being hydrogen, its only emissions are water. Nice. It's actually pulling about 9 kilowatts right now. So don't know what the actual max load is, but that's pretty sweet. And you can just adjust, hook it up to whatever amount of hydrogen you actually need. So for this, I don't know how many kilograms of hydrogen they brought. That's the only challenge with hydrogen is in some cases it's hard to transport, and maybe there's certain safety precautions where just a normal EV battery wouldn't necessarily have those same precautions.